the theory of machining, and I want to give you some insight into it. So we worked a little bit on the lathe last time, and that was cool, and we're going to work a little bit on the mill today. And what I want to do is I want to make it clear to everybody exactly what it looks like to kind of do the like theoretical calculation and then go and actually do it hands-on. So let's call this little short impromptu talk like the more chips in a day, the more pay. Okay? Let's go with that. There's 3 types of ways to make chips. First is you can drill stuff out. Number 2 is milling, and number 3 is turning. And we just want to kind of remember that we're rooted in mechanical engineering. So let's look at this from a mechanics point of view. If we've got kind of a 3-dimensional space, right, and we're applying force to stuff, this is implying that that stuff is moving, right? And so like when we think about machining, we only have 3D to work with. And so there's a reason that we picked those machines above all others, and those became the standard, all right? And so like there's only a couple things that we can do, right? We can have moments, you know, X, Y, Z. And we can have forces, right? 1, 2, 3. So we can sort of force our own view of the situation onto machining. We can go like left to right, right? We can go up and down, and we can go back and forth, something like that, right? So let's forget the sciencey terms for a second, and let's just consider this. This is what we need to be able to do to be able to cut material. And so the easiest thing is just like when we learned about pulling a tensile specimen. It's 1D, right? So the 1D setup is just like this gets us up to down. That's it. So like that's cool. We can make holes. So step 2 is to say, okay, well, how can we take this to the next level? And the answer is, well, be able to go up to down, but then be able to go left to right and front to back. And so this is sort of like the 1D setup. So it's 1D. And we can sort of say we have like 2 to 3D instantly when we go and we look at a mill. And so we've got kind of this 3-axis setup on the mill. And what you'll see today when you go up to the mill is you'll see like, okay, like you'll be like cranking and cranking and cranking and cranking and cranking and cranking. And then you say, you know, oh man, like it was obvious that this should become automated, right? It was totally obvious. And so that's what people have done. And what they did to make it become automated is they set up a computer numerical control to automate it, right? And that's the idea of CNC. CNC, computer numerical control, is just exactly a way of computing where to go in order to cut out a specific geometry. You can have 3-axis, you can have 4-axis, you can have 5-axis, you can have 6-axis, and it gets pretty insane. And it's like, well, what's the deal with that? Because I mean, we only have this, right? This is like physical reality. How many axes do you want? Eventually you get to the point where you're like, I don't want any more freaking axes, right? So it doesn't take long to get there, actually, after the 3D setup. We essentially need to remember that there's sort of a cutter, and then there's sort of a cuttee. That's our part. And so our cutter lives in a coordinate system. And then our cuttee also lives in a coordinate system, right? So what we have is we have a situation where this thing can move, or this thing can move, or this thing can move and this thing can move, right? Or, you know, you could put more than one cutter at the same time, and then it's just like crazy. And you could imagine some sort of crazy contraptions that you could easily make. But there's a reason why we don't make those, and manufacturers don't use those. right? And the reason is because it'd be stupid and it's easier to do it the simplest possible way. We can move like this, we can move like this, we can move like this, or we can rotate. And so you can get up to then, with cutter and cuttee, you can get up to 12 axes. Absolutely insane and ridiculous. Absolutely no need for that. There's machine manufacturers that will make that for you, but that doesn't mean you should buy it, right? So most common is basically this is going to rotate about one axis. Right? This is rotate 2 axis. This is rotate 3 axis. Right? That's the idea. Okay? So now you know CNC. This leads into this idea of rotation, leads into sort of this interesting in betwixt and between setup of, oftentimes people will call it a 2 to 2.5D setup. And instead of sort of having a cutter and a cuttee that move nice in plane linearly, we're really focused on this cutter can move, right? It moves back and forth. And let's call forth this way this time. And then what we're doing is we've got sort of our work piece, and we sort of just touch off on this thing while this thing is rotating. So you've got now this idea of the front to back, but we can also, as we saw, move it left to right. So the way that people talk about this is they say 1D, 2D, 0.5D, something like that, right? Because it's pretty constrained. It's not sort of this freedom of rotation necessarily that corresponds to a true 3D setup. Can't do everything on a lathe. But somehow these are the 3 tools, and these are the 3 processes that have made it as industry standards, okay? And that's the 3 fundamental machining modes that we need to be comfortable with.